Hello. In this video, we will give an introduction to object-oriented programming. This is a very popular programming methodology that is in wide use among software developers around the world. Java is what we call an object-oriented programming language that is designed to help build programs using this methodology. We will go into details about how this might help us think about the program development in a more natural way. That is, by building programs that emulate the world around us. So let's take a look. Key observations. Software is really a simulation of the real world. We simulate real-world events using the software we build. We know approximately how the real world works, so we attempt to design software to simulate real world and learn about events. Software is also used to run every part of our lives today. So it makes sense to design software to model the real world. Obviously, software exists in the virtual world, but the real world is what we are trying to emulate. Therefore, it makes sense to simulate the world using a programming methodology that emulates the real world, which we call object-oriented programming, or simply OOP. So far we have seen what we mean by procedural programming. Procedural programming is about taking a complex problem and writing procedures to simplify and solve the problem. We call that divide and conquer. The procedural programming allows us to modularize our programs and allow us to maintain them easily. In procedural programming, we tell the computer what to do. We can call them sort of verb-oriented. In object-oriented programming, object is the one to model. Objects have attributes and behaviors. Object-oriented programming is a programming paradigm based on data types. Each object has some data types, so you can think of a human is some sort of a data type with certain attributes and behaviors. We can identify things, or objects, that are part of the problem domain, and any object in the real world have some properties. We call them instance variables in the object-oriented programming, and they can do something. We call them behaviors or methods and procedures. So essentially what we do in object-oriented programming is to emulate the real-world object using a virtual world description. There are some essential questions we need to ask. Sometimes it's easy to emulate the real world using objects, and that can make the program easy to write. Because attributes and behaviors of an object are what we call encapsulated, it makes it easy to find errors and maintain programs. We would also like the programs to be correct and efficient. Let's talk about the essential features of object-oriented programming. Encapsulation is the ability of an object to hide sensitive information and disclose only the public information. The type of variables are of utmost importance. Java enforces types, for example, cannot assign a string to an integer, and makes the program safe. So essentially, type checking allows us to avoid and find errors in programs. By using object-oriented programming design, we can build classes of object types that others can use. For example, we can develop a point class, a student class, that others can adopt to their programs. We can protect the data from changes by outsiders, because the objects can protect its own state. For example, we would not allow someone to change our name without our permission. So object-oriented programming is simply what we call OOP, is the process of thinking about programming objects in a situation, instead of thinking about subtasks, or what we call functions, procedures, and method. Of course, object-oriented programming involves functions, procedures, and method. Those are called behaviors. But to solve the primary task, we usually think of, in object-oriented programming, we think of potential objects in our programming environment and their properties. For example, we can think of an object class called car, where it captures the generic nature of a car and specific instances of the car called Polo, Mini, Beetle, etc. What is the generic form of a car? Any car has some attributes like color, size, model, number of passengers, the weight, and so on. Any car has a set of standard behaviors such as cars can go forward, stop, slow down, increase speed, decrease speeds, etc. So this class template will capture all those behaviors into one template that's a common behavior. So as you can see, now we can encapsulate the state of the car or attribute its attributes and its behavior into one package. So each car can have its own unique appearance, such as a green for polo cars and so on. All cars are created from this one template, so they all inherit the properties or behaviors of the car template, but they can have their own instances of color, weight, and other attributes. So objects are specific instances. For example, Bob is an instance of a human class. Lassie is an instance of a dog class. Once an object instance is built, then its primary attributes cannot be changed. In technical terms, this is the time the program assigns specific memory for the object, and some of that memory can be changed, or some of them cannot be changed. So classes are just templates that describes how to build the object. So first you start with a class, and then using classes you can build specific objects of that class. In other words, we call them objects are instances of class, or we say we can instantiate a class object using a class template. Here's an example of a student class template. For example, in this case, we have a student class with a number of attributes that are private. It's important for the class to hide its attributes from the users so that the other users cannot change them without the permission of the class. So in this case, we have last name, first name, and GPA and student ID are the 4 attributes of this class. Obviously, this is a very simplified way to define a student. This is very simplified. Obviously, more comprehensive student class may involve many other attributes. In this design, we only consider last name, first name, GPA, and student ID. The procedure student is a special procedure called the constructor. The constructor's job is to create objects from the template, unless specific students are created. So for example, you could say that the constructor always create the first name Doe, last name John for this student. So it can only really create one student in this case. And the getName allows the object to send the name of the class to the other side. So objects are constructed using a set of given attributes. For example, when we are born, we are given height, weight, body shape, among many others. Objects can be used using their behaviors. For example, we expect a dog object to have the attribute like run. Objects can be destroyed when we do not need them anymore. Of course, we would not do this to objects in the real world, but it is fine to destroy objects in virtual worlds because there are really some memory allocations that is expected to have some time limits in existence. So let's take a look at the constructors. What does a constructor look like? A constructor is a special function that is only used once during the instantiation of an object. For example, consider the pair of dice class here. Note that the constructor of the class take 2 attributes, value 1 and value 2. We pass 2 integers to create one of these pair of dice objects. So what it does, it takes these 2 things through the argument and then assign them to the pair of dice class here. Ideally, we would like this to be private. In this case, the author of the textbook has designed them to be public, but they should really be private. And this class called pair of dice has a specific behavior, only one behavior called roll. What it does is to roll the dice by setting each of the dice to be a random number between 1 and 6. So it's just a way to get a random number using the math class. Math class has a procedure called random. You can get a random number, and this math will make sure that it is a number between 1 and 6. So if you roll the pair of dice, you will get one number for die 1, one number for die 2. They're both random numbers. So objects encapsulate the behavior or what we call procedures and functions, or the state or the instance variables. So let's go ahead and design our object design called Carol the robot. And this is a very simple design. So we think about what does the robot contains. Let's suppose that robot lives in a grid with walls. The robot cannot go out of this grid. Streets go horizontally and avenues go vertically. Corners can have beepers. So a robot can place beepers as if there are no beeper in the corner, it can put a beeper there. So a robot can have the following behaviors. It can place a beeper, it can pick up a beeper, go 1 block forward, or turn left 90 degrees, and turn to the opposite side. So how do we design Carol? We have to think about the Carol, the attributes. In other words, what are the instance variables that defines the Carol? It's the robot ID, and what direction? It could be east, west, north, south. Robot position, it's given as a point with x and y coordinates. Has a beeper, which is a Boolean variable that is either true or false. Total beepers is an integer which has a number associated with it. The max beepers is how many beepers a robot can keep. By using these attributes, we can define as many robots as possible, and each robot can be have a different ID, different direction, different position, different number of beepers, and so on. Now all robots display certain behaviors. Like, for example, a robot can pick a beeper, place a beeper, move 1 block forward, turn left, and turn right. You can see that if you have turn left, you might be able to design turn right function. We'll do this in an exercise. So next we're going to look at from design to coding. How do we take this design and convert that to a piece of code? We'll take a look at that. Now let's take a look at the potential design of the Carol the robot class. So we note that the instance variables or the attributes of this robot or any robot belongs to this class is the robot ID, robot position x, that's the x coordinate, and the robot position y, and whether the robot has a beeper or not, and how many beepers the robot has, and what is the maximum number of beepers the robot can carry. The accesses are the public methods. Note that these are all private. We want to declare all the attributes to be private. Unless there's a reason for them to be public, we always make them by default private. The accesses we call are the public methods that allows anyone from outside to get the robot ID, get the robot position, get the robot X position, Y position, and whether to know that the robot has a beeper or not, and get the total number of beepers. Notice that they're all of certain type. And there are a bunch of methods called set methods. They all start with the word set, as much as this word starts with the word get. The set methods are mutators. That means it changes the state of the robot. For example, it can set the robot ID at any point. It can set the robot position. When the robot moves to another position, it can set the position. In this case, I'm using a class called point class, which I haven't defined. We will do that later. So we pass a point to the robot position. Robot position can be set using that. So this means setting the robot position X and robot position Y. We can see whether the robot has a beeper or not by calling this method or procedure called getHasBeeper, and so on. So here's the constructor. Notice that the constructor is a special method, but it has no return type. That's how we know the constructor. And the constructor share the same name, exact same name as the class name. So the constructor's job is to create a specific robot. That's what the constructor does. So in this case, it will create a robot with the given ID, and it will start the robot at the 0, 0 coordinates. That's like the origin. And then robot has a beeper is false. Robot has no beepers so far. And max beepers is going to be the number of beepers that the robot can get. It's a random number between 1 and 6. And in fact, we can make the robot has beeper equal to true, because what we will do is we will give all those beepers, the random number of beepers, to this robot that we create. There are a number of methods that you asked to write, like pick beeper, place beeper, move one forward, turn left 90 degrees, and turn around. In the coming parts of the video that we will develop these methods to show that how we complete the robot class, and then use this robot class in a driver program to use its behaviors and attributes. Now let's take a look at how we use the design, the class design, the Carol the robot. This is a template or class that we will use to create a specific robot object. So for that you need a driver called robot driver. The robot driver is the one who utilizes the Carol the robot class. So in this case we create a specific instance of a robot called myRobot, which is a new Carol the robot with the ID 2345. Note that the Carol the robot has a constructor which allows us to create a new robot just by passing an ID. So in this case, Carol the robot has a specific direction and specific number of beepers and so on. Now then we ask the Carol the robot to move one forward. If the Carol the robot is created at the 0, 0 position, it will move by default. It will always be created facing east. Let's assume that our constructor will be created using a robot facing east and starting at 0, 0. So moving one forward means you're moving one block east. Turn left, you're now facing north. Then go 5 blocks forward. Now you have gone 5 blocks forward. And then you turn around. You completely reverse your direction. Now you're facing south. Then you move one forward. You're coming down one cell down. So now we'll have a number of questions for you to answer using this thing. And you can answer them in the questions section of this video.